So good day, and this is another intensive class with Peter, STEM with Peter. So the last class I dropped mathematics. So today is physics, and this is a very interesting topic. And this is a topic that usually comes out almost every year in JAM. It's a topic that cuts across every year in JAM. They don't miss out on work energy and power. So let's treat work energy and power, and let's see how it goes. So we are going to be treating the basics first, the theoretical aspect, before we move down to the calculation aspect. We cannot neglect the basics and the theoretical aspect just because we want to deal with the calculation aspect. Now, work is done when a force moves an object through a distance in the direction of the force. I want to assume that as a physics student, up until your stage, you should have an innate knowledge and adept knowledge of what work is. Now, there are two words that are very much common here, which is force and distance. Force and distance. Now, there's a misconception about work, and the misconception about work is that work can be done while standing on a particular spot. Well, to an extent, in the layman world, that is absolutely correct. But coming down to the world of physics, that is not correct. That is inaccurate, because a distance has to be made for work to be done. Force might be applied, but once the distance is not there, then that cannot be considered to be work. Now, I just try to summarize a lot of things in order not to waste our time. Now, it's a scalar quantity. Now, the jam question I asked you, I've seen a lot of students that they don't know the difference between scalar and vector quantity. They don't know the difference between scalar and vector quantity. Maybe perhaps in the next class, we are going to be touching few points on scalar and vector. Now, I've seen the jam question that I asked her, is work scalar or vector? The jam question will just say, is it scalar or vector? Now, many students will feel, what is scalar, what is vector? It's not for this class, it's for the next class. Now, it's a scalar quantity that is measured in joules. Now, the most important thing you need to recognize in physics is the formulas. Once you can master the formulas, then you are good to go with any question. Now, work, if the force is applied in the exact direction of the motion, if the force is applied in the exact direction, what it means is that the motion at which, if I'm heading, now I'm going to give you an instance. If I'm heading to my right, or if I'm heading to east, now, and the force is also applied, in this manner, which is horizontally. Now, what the formula is trying to tell us is that once the force is applied in the same distance or in the same motion at which our object is, or the work is going, or anything, now, what it simply means is that the force will be multiplied by the distance. The force will be multiplied by the distance. Now, let's take it for instance that let's say I'm trying to cover 5 meters. I'm trying to cover 5 meters. And I have applied a force of 4 Newton. What it simply means, in order to calculate the work done, what I'm simply going to do is to multiply the force by the distance, which gives me 5 multiplied by 4, and that gives me 20. That gives me 20 joules. That's 20 joules. Now, that's that. Now, if the force is applied at an angle theta, don't forget that there are different signs that you need to know in physics. We have theta, we have alpha, we have beta, we have gamma. There are a lot of things that you need to know if you are going to be a good physicist. Now, if the force is applied at an angle theta to the horizontal direction of motion. Now, if you have done equilibrium of forces, you will realize that when you are dealing with horizontal, we are using cos theta is when we are dealing with horizontal. But when you are coming down to the vertical, then we are using sine. So according to this is very straightforward. Now, if the force is applied at an angle theta to the horizontal direction of the motion. Now, this illustration I just demonstrated is moving directly to the horizontal. So if I'm going to do this, let's assume that I was given an angle of 25 degrees. An angle of 25 degrees. All I need to simply do is, once I have my 20 joules, for the work done, moving to the same direction. Once I have my 20 joules for the work done moving to the same direction. Now, all I need to simply do is now, I'm going to multiply this F times D multiplied by cos theta. Or if you don't want to do it that way, you can first of all get your cos 25. You can get your cos 25. Whatever your cos 25 is, we are multiplying it by the distance, and then we are multiplying it by our force, which is going to give us the work done. Always remember that the unit of work done is joules. Sorry, hold on. Always remember that the unit of work done is joules, because I've seen many students fail exams just because they don't know the unit that they are dealing with. The question might put 20 Newton, 20 joules, 20 watts, 20 meters. So if you don't know what you are dealing with, then you are liable to get every question incorrectly. Now, let's move directly to energy. Energy is the ability to do work. Energy is the ability to do work. It is a scalar quantity that is also measured in joules. Work done is equals to the change in energy. So I'm going to say that I can refer energy as the capacity. That's what I'll call it, as the capacity. So the larger the energy, the larger the output of the work done is. The larger the energy, the larger the output of the work done is. Now, let's move directly to power. We still have a lot of calculations to attack today. Power. This is the rate at which work done. This is the rate at which work is done or energy is expended. Power is measured in watts or joules per second. Power is measured in watts or joules per second. Now, power is actually deeper than work done, in the sense that power can also cut across a lot of topics. Power can cut across electricity as well. Now, this is the rate at which work is done. So, take it for instance that if I am digging the ground at the rate of 10 digs per second. 10 digs per second. So if I'm digging 10 digs, I dig 10 digs per second. And another person is doing 40 digs in 1 second. 40 digs in 1 second per second, rather. 40 digs in a second. Now, this is attributed to power. This is attributed to power. So what this simply means is that the rate at which, or the power at which this person is expending is 10, and the power at which this person is expending is 40. And so this person is going to generate a higher output than the person with 10 D per second. And don't forget that this power as well is dependent on the energy. Power is dependent on energy. Energy is not dependent on power. It is power that is dependent on energy. So it means that the higher the energy, or the more the energy, the higher the power will be. The higher the energy, the higher the power will be. So this 40 digs per second. So if somebody is digging 1, 2, 3, 4, 8, the sole reason why he's doing that is attributed to his energy. Now, power is measured in watts or joules per second. Power is measured in watts or joules per second. Now, a good example of what is your light bulb at home. Now, have you ever seen 60 watts, 20 watts, 30 watts, but you don't know what they actually mean? But it's not for this class. I'm going to explain that in the lesson. Now, power is equals to work done over time. Power is equals to work done over time. That is W over T. Now this is a very critical one. Since work done, now I'm taking you back to the first formula. it took me a lot of time to summarize this note to put it adjust, mend and attack. Now, since work done is equals to force times distance, don't forget that you have been told that power is equals to work done over time. And now work done, take this work done here, take it back to the force times distance. Take this work done, force times distance. So it simply gives you, anyway, you are substituting work done to be force multiplied by distance. So it means that anywhere we are saying work done, we are going to simply input force multiplied by distance. So now, force multiplied by distance over time. This gives us our what? Our power. This gives us the formula for power. And don't forget that velocity can also be said to be distance over time. For my basic physics student, velocity is distance over time. So it means that anywhere I see distance over time, I'm going to substitute it to be v. So instead of writing d, distance over time, now look at this formula. We have been told that p is equals to force times d over t. Now look at this. Now, and we've also been told that d over t is velocity. So it means that I can take this one to be v. So now my power can be F multiplied by v. That is force multiplied by velocity. Depending on the question. There are some questions that you might be required to use force multiplied by velocity, and there are some questions that you might be required to use your force times distance divided by time. So depending on the question. Now let us proceed. Let's proceed. For the last theoretical part, we proceed for the last theoretical part. Now, we want to move to energy. We are still on energy. Now, I'm not going to dwell much on this. Now, kinetic energy is half multiplied by mv squared. Half multiplied by mv squared. The difference between kinetic and potential energy is that one is at rest while the other one is not. One is simply just, one is when they say something potential can still be at rest, but it's still looking for a way to what? A way to activate. It's looking for a way to activate. Now, energy can neither be created nor destroyed, but can only be converted from one form to another. In an isolated system, the total mechanical energy remains constant. There's a formula that I did not put here. The total mechanical energy remains constant. Now, when they say it remains constant, this is what it means. Kinetic energy plus potential energy is equals to constant. Kinetic energy plus potential energy is equals to constant. So this is it. So for instance, the question might not give you the constant, but the question might give you your kinetic energy and the potential energy. Automatically know that in your brain that you must add your potential energy and the kinetic energy in order to get your constant. Now, I just put a damn shortcut there. Now, there are some questions that will require you that before the object hits the ground, at a particular height h, the formula to use is your mgh, which is your potential energy, is equals to your kinetic energy. The potential energy